What if an algorithm could tell you, with 91% certainty, exactly where the next naval clash will explode in the South China Sea before a single shot is fired? That's not science fiction. Researchers are now using AI-powered pattern recognition to analyze thousands of data points, from spoofed ship transponders to satellite imagery of Coast Guard formations, and the predictions are keeping defense planners awake at night. This is the story of how machines are reading the ocean's warning signs and what it means for the most contested waterway on Earth. To understand why an algorithm is now the South China Sea's most honest broker, you have to understand the layers of grievance beneath the surface. In 1947, the Republic of China drew a U-shaped line, 11 dashes at the time, claiming virtually the entire sea. When the People's Republic was established in 1949, it inherited and simplified that claim to 9 dashes, asserting sovereignty over roughly 3.5 million square kilometers of ocean. That boundary overlaps with the exclusive economic zones of at least 5 nations, a legal impossibility under the United Nations Convention on the Law of the Sea. For decades, these overlapping claims simmered in diplomatic back channels. But starting in the early 2010s, China began transforming submerged reefs into militarized artificial islands, airstrips, radar installations, anti-ship missile batteries, on features like Mischief Reef, Fiery Cross, and Subi Reef. Between 2013 and 2016, China reclaimed over 3,200 acres of land in the Spratly Islands alone, more than all other claimants combined in history. The Philippines brought a case before the Permanent Court of Arbitration in The Hague, and in 2016, the tribunal ruled overwhelmingly against China, declaring its 9-dash line had no legal basis. Beijing rejected the ruling entirely. And that rejection, that moment when international law was openly defied, is the fault line every AI model is now trained to monitor. The South China Sea conflict isn't a two-player game. It's a 5-dimensional chess match with nuclear stakes. China, the dominant force, deploys not just the People's Liberation Army Navy, now the world's largest fleet by hull count with over 370 vessels, but also a shadow armada. Its maritime militia, composed of hundreds of fishing vessels trained to swarm and intimidate under thin civilian cover. The Philippines, under President Ferdinand Marcos Jr., has dramatically shifted from his predecessor's Beijing-friendly posture, granting the United States expanded access to 9 military bases under the Enhanced Defense Cooperation Agreement. Vietnam, the quiet claimant, has quietly built up the second-largest set of features in the Spratlys and maintains a sophisticated anti-access strategy of its own. Taiwan, whose very existence China contests, controls I2ABA, the largest natural island in the Spratlys, and its presence there complicates every scenario. And then there is the United States, which claims no territory but asserts its right to freedom of navigation through these waters, conducting regular patrols that Beijing calls deliberate provocation. Each of these actors generates thousands of data signatures every day: radio transmissions, fleet movements, diplomatic statements, procurement contracts, and it is the aggregation of these signatures that gives AI models their predictive power. Here is where it gets genuinely alarming. Researchers at the Center for Strategic and International Studies and independent open-source intelligence analysts have documented a dramatic surge in what are called pre-kinetic signatures, behavioral patterns that historically precede armed conflict. One of the most revealing datasets comes from the Automatic Identification System, the transponder network that tracks commercial and military vessel movements globally. In the South China Sea, IISS spoofing has become epidemic. Over 1,200 ghost vessel tracks were detected between 2022 and 2024, positions broadcast by ships that either didn't exist or were deliberately masking their true locations. Chinese maritime militia vessels routinely disable their transponders in what analysts call going dark, then reappear near contested features in coordinated formations. Machine learning models trained on these deception patterns, combined with satellite imagery analysis of Coast Guard buildups, changes in radio frequency emissions, and natural language processing of state media rhetoric, have produced conflict probability scores for specific zones. Reed Bank, where the Philippines has sovereign rights to vast hydrocarbon reserves, scores at 91% likelihood of a significant maritime incident within the next 24 months. Second Thomas Shoal, where a grounded Philippine Navy ship serves as an outpost and has been the site of repeated water cannon confrontations, scores at 88%. Scarborough Shoal, the flashpoint that nearly triggered a U.S.-China standoff in 2012, sits at 74%. These are not hypothetical numbers. The Second Thomas Shoal is already a live stress test. In 2023 alone, Philippine resupply missions to the BRP Sierra Madre were intercepted by Chinese vessels at least 6 times, with water cannons, military-grade lasers, and deliberate ramming employed as harassment tactics. Each of these encounters generates data. Each data point makes the next prediction sharper. What makes these AI models particularly powerful and particularly dangerous is their ability to detect what human analysts miss. Traditional intelligence relies on reading intent from rhetoric, and states have every incentive to bluff and misdirect. But algorithms don't care about press conferences. They care about patterns. When Chinese Coast Guard deployments to a specific shoal increase by 340% over a 6-month window, when maritime militia vessels begin clustering at night with transponders off, when state media shifts from historical grievance narratives to language about defending sacred territory, the neural network flags the convergence. It doesn't interpret intent. It maps probability. And that distinction between understanding why a conflict might happen and predicting that it will happen is reshaping deterrence theory in real time. So what happens when these predictions become standard operating procedure for navies? The concept is called algorithmic deterrence, and it's already being developed in classified settings across the Pentagon and allied defense ministries. The idea is simple. If both sides can see the conflict probability scores in near real time, does that transparency prevent escalation or accelerate it? Some strategists argue that AI-driven early warning creates a circuit breaker, giving diplomats a window to intervene before a confrontation crosses the kinetic threshold. Others fear a darker outcome, that automated predictions become self-fulfilling prophecies, where military planners preemptively reposition forces based on algorithmic threat assessments, and those movements themselves increase the predicted risk. The United States is already investing heavily in what it calls Project Maven-style programs adapted for maritime domains, using computer vision to analyze millions of satellite images of Chinese naval facilities and detect preparations for large-scale deployments within hours rather than days. China, meanwhile, is building its own AI-driven command systems, and the risk of 2 competing algorithms misreading each other's pattern of life as pre-deployment activity is not theoretical. It's a scenario defense planners are actively wargaming. The South China Sea has always been a test case for international law, for great power competition, for the limits of diplomacy. Now it's a test case for something entirely new. Whether artificial intelligence can be trusted to predict the future of war, and whether that prediction changes anything at all. The algorithms are watching. The question is whether the humans in charge are listening.